Okay, let's take a look at this part. It says the degree of a polynomial function affects the shape of its graph and determines the maximum number of turning points, or places where the graph changes direction. It also affects the end behavior, or the directions of the graph to the far left and to the far right. The table below shows you examples of polynomial functions and the 4 types of end behavior. The table also shows intervals where the functions are increasing and decreasing. A function is increases when the y value increases as x values increase. A function is decreasing when the y values decrease as the x values decrease. So let's take a look at this function. So we have an end behavior of up, up. We have turning points at negative 1.07 and negative 1.04, and again at negative 0.27, 0.17, and again at 0.22 and negative 0.15. So those are my turning points. And so those turning points are here, here, and here. All right, so the function is decreasing. So decreasing, I'm looking at it like I'm looking at a book from going from left to right. So when x is less than negative 1.07, it's decreasing. So here I'm decreasing, right? Even though that arrow is pointing up, it's actually decreasing. Then going this way, I'm increasing. And I stop and I start decreasing again. Then I stop and I start increasing again. All right, let's take a look at this one. You say the end behavior is down, down. My turning point is at 1, 1. Here's my turning point here. The function is so here, from here to here, I am increasing. I'm looking at it like I'm reading a book. And then when I get here, I start decreasing. And you can look at the function notation that they provided as well. All right, the next one, my end behavior is down and up. The turning point is at 0. The function is increasing for all values of x. So here I have, looking at it like I'm reading a book from left to right, I am constantly increasing. All right, here I have up and down. I have turning points at here and here. These are my 2 turning points. And I look at it like I'm reading a book. So first I'm decreasing, now I'm increasing, and then I'm decreasing again. All right. You can determine the end behavior of a polynomial and the degree n of degree n from the leading x term. So a, positive, up, up. Odd, positive, and even is up, up. Positive and odd is down, up. A is negative, even is down, down. Negative, odd is up, down. All right. In general, the graph of a polynomial function with degree n, where n is greater than or equal to 1, has the most n minus 1 turning points. So those are the maximum amount of turning points that it can have, the number minus 1. The graph of a polynomial function with odd degree has an even number of turning points, and a graph of a polynomial function of even degree has an even number of turning points. So describe the end behavior. Okay, I'm sorry, going too fast. Let's take a look at problem 2, describing end behavior of polynomial function. It says, consider the leading term of each polynomial function. What is the end behavior of the graph? Check your answer with the graphing calculator. Okay, so here I have a positive degree and I have an odd. So since n is odd and a is positive, the end behavior is up and down. Let's take a look here. Here my a is negative and my n is even. So since n is even and a is negative, the end behavior is down, down. All right, let's take a look at the guide. It says, consider the leading term, negative 4x to the third plus 2x squared plus 7. What is the end behavior? So here it is negative and it is odd. Oh, I'm sorry, I forgot to check it by graphing. I'm going to use my free graphing calculator at www.desmos.com. It's free to use. Please use it. Absolutely free. And let's do 4x to the third minus 3x. Okay, and so here it is, just like what the book said. Looking for the book. So the book said that we have a down and up. So we have down and up. Okay, let's do the next one. Negative 2x to the fourth. Plus 8x squared, I believe. No, 8x cubed, sorry. Minus 8x squared plus 2. Alright, so notice it is down. Alright, now we'll do ours. So got it. And so, like I said, we have a negative a and an odd number. So since it's negative, it's going to be up then down. And we can go back to our little chart that they gave us. Negative, odd, up, down. Let's graph it and verify that. Let me look at the equation. Y equals negative 4x to the third. Plus 2x squared plus 7. Okay, well, that one's harder to see, but let's see if I can zoom out. There we go. Okay, and so notice it's going in the opposite direction, and I hope that this helps.